Hey, 7th grade team. Thank you for coming to the planning day on Wednesday. After our conversation about skewness of box plots, I thought you guys deserved a better explanation than the one I was able to come up with on Google. And you know what? It turns out the field guide had a mistake in it about skewness. The graph that it says is skewed to the left is not skewed to the left. It's skewed to the right. So what does it mean to be skewed? Well, let's talk about that in a minute. The first thing you need to know is that the term skew is not going to show up on the STAR test. We looked at, the facilitators, all of us looked together at all the past examples of box plots on the STAR test, and they don't really talk about skewness. What they talk about is whether or not the graph is symmetric. They basically compare the median and they compare the symmetry of the graphs. Let me make a little chart for you. Here's what your kids need to know. When data is symmetric, we use the mean to describe its center, and when data is asymmetric, we use the median to measure its center. So let's say that you're comparing two different sets of data. You're looking at two different box plots. If either one of those sets of data is asymmetric, compare the medians. That's how you're going to compare the centers of those two sets of data, is using the median if either is asymmetric. If they are both symmetric, you can stick to the mean. And to measure the spread, you're going to look at the inner quartile range. So this is what your kids are likely to see on the STAR test, the words symmetric, mean, median, and the inner quartile range. In fact, most of the time they're going to be comparing an asymmetric to a symmetric or two asymmetrics. Really what they're going to see is the median and the inner quartile range. And then is the data symmetric? This is what your kids need to know this year. They need to know, is that data symmetric or not? They need to be able to compare the medians of two box plots, and they need to be able to measure the spread using the interquartile range. They might compare, is the range of one box plot bigger than the range of another? Let's look at 3 box plots based on a few phone numbers. My phone number, my husband's phone number, and Tommy Two-Tone's phone number. Nobody really knows Tommy Two-Tone's area code, but I'm going to say it's 214. So let's line these phone numbers up and get them in order. Now that we've got them in order, it's going to be pretty easy to find the median. So there's our median, 7.5, 2.5, and 4.5. The quartiles are even easier to find in this case. There's the quartiles, so let's draw some box plots. Start out with some evenly spaced number lines. In this case, since we're using phone numbers, we only need to worry about 0 through 9, so this is going to be easy. So the whiskers for my phone number are going to be 1 and 9, and now I can see the range of my data. So once you've got those, you've got the range. My median is at 7.5, so check it out. It is way over here on the right. My phone number is kind of weird because one of the quartiles happens at 4, but the other one happens at 9. Why is that? That's because I have 5 9s in my phone number. So my phone number creates a box plot that's actually an example of a box plot that is missing a whisker. Since my quartile occurs at 9, see those 1, 2, 3, 4, 5 9s? The 9 is my third quartile, and it is also my maximum value. So I don't have a whisker on my right side. Check out my husband's box plot. It's going to be kind of similar to that. It is also going to be missing a whisker. Here's his endpoints. He goes from 0 to 9, so he has a larger range than I do. And his first quartile is at 0, so he's going to be missing his left whisker. His median is 2.5. Let me mark that. And his third quartile is 7. So his box is going to go from 0 to 7. And then that whisker is going to extend over to 9. Okay, so let's look at Tommy Two-Tone's data. Tommy Two-Tone actually has every single number in there exactly once, doesn't he? Yeah, 8, 6, 7, 5, 3, 0, 9, plus the 214. He's got each of them exactly once. So his range is going to be the same as my husband's. So it's going to go from 0 to 9. His median, however, is right in the middle. It's at 4.5. And then his quartiles occur at 2 and 7. So Tommy's data is perfectly evenly distributed, and we would say it's not skewed. So Tommy Two-Tone's data is not skewed, no skew. My phone number is skewed to the left because the longer part of my graph is over on the left side, and my husband Greg's, his phone number is skewed to the right. The longer part of his box plot is on the right side. So one thing I want to point out to you about these graphs is just exactly where my data is falling in here, because this is something that's easy to overlook. I have one data point at 1 in my phone number. I have 1 at 3. Look, I have 2 at 4. This is why if you do a human box plot with your students, you're going to want them to line up if they have repeat data. And then I have 6. And then check it out. I skipped several numbers, and I have 1, 2, 3, 4, 5 data points on 9. So there are some empty spaces here in my box plot. Notice that nobody is at value 7.5, and 5 people are at value 9. This is what my husband's look like. He has 1, 2, 3 data points at 0, so that's dragging the median down, isn't it? And then he's got 1, 2, 3, 4, and then he skips a bit. He's got 2 7s in his phone number, and he doesn't have an 8, and he does have a 9. I think putting these little dots here, it doesn't actually add anything technically to the box plot, but it does kind of help you understand just exactly where there are data points and where there aren't, and what that box plot is trying to communicate. This is also another thing that was illustrated by that human box plot. This is why it was so key to have those paper placeholders, because the number line, it's spread evenly apart between each integer, right? 1, 2, 3, 4, 5, 6, 7. But that's not the case for the data. That's where those placeholders came in important. Now, Tommy Two-Tone's phone number is special because it has every number exactly once. So in that case, our data is evenly spaced out along the number line. Maybe that's why that song was so popular. So there's just 2 more things I want to talk with you about in this video. One of them is number 46 on the unit assessment. It is fixed now. It does have a correct answer. And I just wanted to show you this is how I would present it to kids based on the changes. I would have them calculate the mean of median, mode, and range of the winners and the losers, and then create a separate column showing the differences between those. Because then it's clear for the kids to see so that they can read those choices and understand them. So this is just my thinking. This is how I put things in order. All right, let's move on to navigators. Inspires. Now, because you guys are very curious and intellectual and just naturally philosophical at heart, let's talk a little bit about beyond the TEKS. So this is going beyond the TEKS. And just explore what skewness really means with box plots, just for fun. So here's a few just really fast versions of box plots here so that we can talk about the skewness. If most of the data is scrunched up to the left, then we say it's skewed to the right. It feels backwards, but it's true. And if most of the data is scrunched up to the right, then we say that that is skewed left. So look at where the box plot is long. If the longer portion of the box plot is on the right, it's skewed right. If the longer portion of the box plot is skewed left, is to the left, then it's skewed left. One day when your kids are in AP statistics, they're going to look at distributions that look more like this. The formal definition of skewness actually compares the mean to the median. If the median is greater than the mean, then you're looking at data that's skewed left, like this example over here. See how our median is to the right of the mean? However, if your mean is greater than your median, then your data is going to be skewed to the right. And of course, the curve in the center here, this one's not skewed at all. There's no skew. This is actually the normal distribution, and the median is equal to the mean. So here's a summary of skewness. But remember, your kids don't need to know it at this level. So if you're tired of hearing about my phone number and my husband's phone number, I'm sorry, because this example is also going to be about our phone numbers. But it works out really well for box plots. Check it out. Here's what we want to do. The first thing is we want to open a new document with lists and spreadsheets so that we can write in the 3 lists. So this is going to be me, This is going to be Greg, and this is going to be Tommy Two-Tone from the 1980s. So here's my phone number, 469. Okay. And my husband, so we're just entering in the data. Oops, I forgot his area code. And then, let's see, we said 214 was Tommy Two-Tone's, and 8675309. Okay, so we want to do a box plot, and I'm actually going to graph 3 box plots on one axis. Brett and Lisa stayed and figured out how to do this the other day. So first I need to add a page to this. So I'm going to do Control Doc to add a page, and I want to add data and statistics. So there's my, essentially my scatter plot. I want to add an X variable. Guys, we are not going to add a dependent variable this time. We don't want to compare one axis to another. We're only looking unilaterally at each variable. So I'm going to add an X variable. Let me add my husband first. So there's Greg's phone number. And let me go to Menu, Plot Properties, Plot Type. I'm going to make that a box plot. There he is. And remember how we said he didn't have a left whisker? That's why. That's because he has all those zeros. So now the next thing I want to do, I'm going to go back to Menu, and this time I want to go to Plot Properties. You'd think I would add a Y variable, right? Don't add a Y variable. Remember, we don't want a dependent variable. We only want to compare 3 different independent variables. So we're going to add an X variable, and this time it's going to be me, my phone number. Oop, there it is. And remember, I don't have a whisker on the right side because I have 5 9s. So let's add one more. This time we're going to Plot Properties again. We're adding another X variable. And this time we're going to add Tommy Two-Tone. There he is. And now his is perfectly symmetric, isn't it? So the median of my husband's plot is less than my median. And my median is actually the greatest median of all 3. In fact, the median of my phone number is greater than the 3rd quartile of Tommy Two-Tone's. The spread of Tommy Two-Tone's and Greg's is the same. They have the same range. My range is slightly smaller. Now, my data, remember, is skewed to the left because the longer part of the box plot is on the left side. My husband's is skewed to the right. You can also confirm that using the definition. See, the mean of my phone number, I calculated as 6.3. Well, the median is greater than the mean, so therefore it's skewed left. My husband's mean is 3.3. 3.3 is greater than his median of 2.5, so therefore his is skewed right. Now for Tommy Two-Tone, the mean and the median are both 4.5, so there's no skew there at all. Of course, when you're talking with your kids, you're not going to talk about skewness. You're going to talk about whether or not it's symmetric. Thank you guys again. I really appreciate you. It was great to plan with you on Wednesday, and I hope this video is helpful for explaining the things that we really didn't get to wrap up.